I hate debugging. I hate the guilt that I get when a user tells me that there's a bug in my software. I hate the mad rush that it causes in me to try and comb through the code madly to find the cause of the issue. And I hate that even if I spend hours and days looking at the code base, I can't be sure that there's no bugs in my code. I can't be sure that I have missed something. And I hate that when I try to use AI to make this faster and quicker and more efficient, I have this real problem where it just injects more bad code into my system, and it makes it even harder to do all of this loop again. And I'm really sick of wasting the brain power and the coding time trying to madly fix stuff when it goes wrong. So I've come up with a system for debugging that lets me get things right the first time. And it basically allows me to identify all of the effects of code in one sitting, pull out the root causes for bugs, and then formulate a solution that doesn't cause regressions. I've been able to get this down to a matter of minutes rather than hours of days. And if you're using AI in your coding, this is going to save you a ton of time, and it's going to save you a ton of tokens, and it's going to save you a ton of back and forth, and it's going to get rid of that mindless feeling that you get when you get stuck in these debugging hell loops. And this is really simple. It's just about putting some guidelines and doing some additional thought before handing it off to Codex and Claude. And you can still get all of the advantages of coding with an LLM with none of the downsides. I just want to get into a few caveats before we get into this. This system will work best if you are using large language models in your analysis process. Code bases are hugely complicated beasts that are hard for any one person to analyze effectively. There's just so much moving pieces that holding all of that information in your head and analyzing it objectively is just not a skill set that most people are good at. Now, this is really important because when I talk about the power of AI, I'm really talking about the ability for it to do data transformations, for it to basically be able to process a ton of data and then transform it into a presentation that's useful for us and helps us get us work done. And what my technique is really about is changing the boundary of the problem so that you can make an effective data transformation that gives you the most leverage on the problem. We can connect the findings and find creative solutions in a way that a large language model can't, and at a much faster speed. And you are really more powerful than any computer at doing this. So we want to make the LLM help us as much as possible to use our own superpowers. So let's get into the process. Step one is analyzing the bug that you know about. The first thing we want to focus on is what parts of the software does this bug touch? What specific systems is it affecting? And we want to extend this analysis into looking at what specific systems are imposing requirements on our bugged system and what specific requirements is our bug system imposing on the other parts of our software. This is a really important thing to understand to ground our software. You should be pretty good at this if you've built your code, but you can also ask your large language model to help you pull out this analysis. It's a very important analysis, and it's going to make everything a lot easier and stop us from being blown off track. So step two is identifying how far the damage goes. So what we want to do is we want to look at the upstream and downstream layers that we found before about how requirements were being imposed. And we essentially want to look in the upstream and downstream layers for if there is any additional bugs or any additional mistakes in the code. Because where there's smoke, there's fire, right? We don't want to miss anything upstream and downstream because that will have big consequences for how we design the solution. So essentially, we'll go through the same process we did in step one for any additional bugs we find, and we'll keep searching until we've covered all overlap. And then what we want to do is essentially group any and all bugs that we've found into cohesive groupings. These cohesive groupings should be groups that have similar impositions on similar systems. The upstream and downstream systems for the groups should all be very similar. So the next step is step three, which is identify the root cause. And our goal in step three is to identify the root cause for each of the groups of bugs we found in the previous step. We essentially are looking for two things in a root cause. We are looking for a business logic root cause, which is the root cause of the issue in terms of your business logic, in terms of how the software has misimplemented what your intent was for the business of the software. But we also need the second part of that, which is the technical root cause, which could be because you used the wrong data type or a syntax issue or a misunderstanding in how the technology works. The reason we want to separate this out into two things is because it's really easy to cause a regression when you describe a bug just in terms of business logic or just in terms of technical logic. By having both definitions, we can make it a lot clearer to the LLM, but also a lot clearer to you personally. What is the reason that this is happening? Because it's always partly business and partly technical. And if you don't have both pieces of the puzzle, you're only going to get half of the solution. Which lets us move on to step four, which is creating a solution that encapsulates the entire issue. With your understanding now of the business logic mistake and the technical mistake, it should be pretty straightforward for you to understand what's going on in order to synthesize a really good solution to this. This technique also gives a really strong foundation for an AI to do this, because there is no ambiguity in how the requirements are imposed, or what the business logic mistake was, or the technical logic mistake, which means you can describe it really easily and get a pretty good solution out of most large language model tools. So I've been using this process for months now, and it works really well for making sure you don't go down a blind alley and you don't suffer from the complexity of these bugs as you fix them. You don't shoot yourself in the foot, and there's no regressions. But it does take a lot of time, and using a naked large language model for doing this is not optimal, because you have to manually manage all of the orchestration and all of the steps and piece everything together. And there's a lot of waiting while you do all of that. So what I've been doing recently is I actually built this process into my tool Dev in a Box. And the workflow I use now is that I'll basically conduct an issue scan. And an issue scan is a tool in Dev in a Box that allows us to put a bug in and basically find any related bugs upstream and downstream in the system. It's basically doing step 1 and 2. I'll do that, then I'll take the results of the scan and I'll manually sort through them and identify these groups, and I'll basically do step 3. And then to do step 4, I'll use the bulk patching feature in Dev in a Box. And this is basically a tool that allows you to generate a step-by-step plan on how to fix all of the bugs in the most optimal way without regressions. And this is a really great tool because you can either hand it off to a large language model to implement, or you can use it as a guide to do it yourself. It's also really great for getting your brain thinking and to basically get all of the information in one place so that you can also synthesize and edit the solution to make it as optimal as you want it to be. I found that this is a faster way to do these analyses, and it saves me a ton of brain space, which is really cool because it's letting me do more interesting and creative development work. So I hope you enjoyed the video, and please subscribe if you enjoyed it, because we're going to be showing up a ton of other really cool stuff. And if you have any tips for how people can debug faster that we didn't mention in this video, please feel free to leave them in the comments below. Thank you so much.